We technically have a closed interval. What's your method? What are you going to do? You're going to find the partial with respect to x and the partial with respect to... Are there any other partials? No. L and W are static. They're just undefined. We're not setting them equal like 6 and 3. We're setting them equal to L and W. Now, before we go about doing that partial, what might be something that would be good to do?
Simplify.
Try to simplify this. Try to clean this up. And my question is, can you... fxy is equal to x squared plus L minus x squared times y squared plus W minus y squared. Now here's the thing. Does anybody know what we just factored? Does anybody know what type of factoring we just did? Does anybody know what that's called? This is pretty much the first time I've ever seen this naturally come up. This is factoring by... Does anybody remember what it's called? Yeah. Factoring by grouping. You usually see factoring by grouping as something that comes up because they say, factor this by grouping. Factor this by grouping. They tell you to use the method. Here's one way it comes up. Anyway, that's just a rearrangement. You don't technically have to do it, but is it mighty helpful?
Yeah.
Yes, it is. Okay, so now we're looking for fx and fy.
And fx, x, and
Correct, because we're going to need to do... So we end up with what? We end up with 2x minus 2l plus what? 2x times this? Like that? So what does that tell us here? It tells us that we end up with 4x minus 2l times this thing, right? And we're particularly interested when that's equal to what?
0.
So we're really interested in when 4x minus 2l is equal to 0. So that 4x is equal to 2l. So x is equal to 1/2 L. So that's the first part of our one critical point. So we're going to do the same thing, but what are we going to end up solving for? Y, because we now need to do f of xy. We're going to do that from our right here. So instead, this stays the same. What is it? X squared plus, is it plus? W minus x? Is it W minus x?
L minus x.
Is it L minus x? Thank you. Thank you. I can't see it. L minus x squared. And now we do functionally the same thing over here. We end up with 2y plus...
Minus 2.
Oh, hold on. I'll do the whole thing out. Yep, plus 2 times W minus
Yeah.
y times -1, right? So we're really interested in when, what is it, 4y plus, is it minus? Yeah, it's minus, thank you. 4y minus 2l is equal to 0. So that's when y is equal to? 2w, thank you. So it equals, it's 1/2 of w. Okay, so here's the thing. Our critical point is now, as we know, our critical point is now 1/2 L comma 1/2 W. It could be a max or a min, so what do you need to run? Ningy, sit up, careful, I know college stuff is challenging.
The
I know.
second derivative test.
Yeah, the second derivative test, so you need D, and that's equal to, what is that? Yep. At that, right? At that point. So if you do this out, what do you find out? You find out that D at 1/2 L, 1/2 W is what? What is it? Is it positive or negative? What do you remember? What did anybody do this? It comes out to be what?
Positive.
Positive. And you also need to know what is fxx, right?
Which is also
At 1/2 L. I gotta stop doing those commas. Whoa, stop it. That's not helpful. There we go. At what 1/2 L comma 1/2 W, you come out that it's positive. So because of this, you know that's a the minimum. And the thing is, does it ask you what the minimum value is, right? I think. Find the minimum and maximum values, right? That's where the minimum and maximum value occurs. So how do you actually find the minimum and maximum value of?
plug it in.
You need to actually do f of 1/2 L, 1/2 W. Did anybody get what it is? Yeah, I think it collapses nicely, doesn't it? Yeah, it's 1/4 L squared W squared. It takes a little while to evaluate it. So though the real question is, the big question is, yeah, be careful of the desk. Sorry, this is the one for this to correspond to the drawing. That would be f of y0 right there, and this would be f of, sorry, 0y. Thank you, 0y, because the x code is right here. Oh no, sorry, I was right. Sorry, this is x0, and the other one is 0y. So you just evaluate the function at those values right there. You evaluate the function at those values. And you end up with, in this circumstance, it comes out to a minimum because your extreme values are going to be h. You try h of 0, you end up with L squared W squared, right? Which is the exact same thing, or h of L. You're absolutely correct. H of L, which comes out to be L squared squared. If you do the same thing over here, you end up with L squared W squared as the max. So that's your super complete version of this proof right there. That's your super complete version. X, Y, Z. Absolutely correct, Danny. Good. Sir. Okay. Okay. That's great. So you know that 8 is equal to lambda times what? 2x. You know that 0 is equal to lambda times what? 20y. Thank you. 20y. And you know that negative 4 is equal to lambda times what? 2z. So therefore, what does y have to be? 0. What do you do from here?
Then you set everything equal.
So what do you get? Like you want to isolate lambda?
You want to isolate lambda first.
Yeah, sure. So what do you end up with? Lambda is equal to
x over 4.
x over 4?
4 over x.
4 over x. Now what?
And we don't do both for y.
Yep. And you know this one comes out to be what? Lambda is equal to what?
Negative 2 over z.
Over z?
Yeah.
Now what do you do?
You set them equal.
So 4 over x is equal to negative 2 over z?
Cross multiply.
Yep. 4z is equal to negative 2x. Yep.
And then set it up as z or x and plug it into the...
Yeah, let's do z is equal to what? Negative 1/2 x.
Yeah.
Do with that.
Plug that into the g to the x, y equation.
Up here?
Yeah.
Like this?
Except there should be a 5 or a negative 5.
You know that x, yeah, you're plugging it into x squared plus 10y squared plus z squared is equal to what? 5. So you plug that in, you get x squared plus negative 1/2 x squared is equal to 5. So x squared plus 1 over 4 x squared is equal to 5.
5 over 4x squared equals 5, which x turns out to be plus minus 2.
X squared is therefore equal to what? 4. So x is equal to plus or minus 2,
Yeah.
right? So you end up with 2, 0.
Negative 1 for the maximum.
Yeah, because you have this relationship, right? X is equal to, you have this right here, right?
Yeah.
Negative what?
1.
Negative 1, and then you have
Negative 2.
0 and
Plus 1.
plus 1, exactly. That's where that's where they occur, but what do you have to do now?
Plug it in.
Plug them in. You plug them in to the actual equation that you're trying to match. It's 8x minus 4z. So f of 2, 0, negative 1. Remember, f of x, y, z is equal to 8x minus 4z. So what's that equal to? 16 minus plus 4 is equal to 20. And f of 2, 0, 1, negative 2, 0, 1 is equal to negative 16 minus is equal to what? 20. Needed a little bit more. A little bit more. Okay. You have to take all the partials, correct? So let's fx1 of this thing. Okay? What's that going to be? 1 over n times x1, x2, all the way to xn to the 1 over n minus 1 times what? x2, x3 up to xn. Exactly. Very good. But what do you multiply this by? And then you know that this right here is equal to, and then let's just do this. G of x1 of x is equal to what? 1. Right? Correct? And you know that f of xi is equal to lambda, or x1, g of x1, right? So what does that mean? The whole thing is equal to what?
Means that f1 equals to.
Yeah, and you know that, yeah, exactly. So if we generalize this a little bit, you know that g of x anything, what's that always going to be equal to? It's always going to be equal to what? 1, right? So you're going to get this thing right here. See this? What's the only thing that's going to change about this? Which one's missing, right? So this first one, that's going to be equal to lambda, right? And then when you do it in terms of x2, you do this in terms of x2, so instead it's going to go from 1 to 3, right? What's that equal to? Lambda. And I'll do one more for you. So if you do this one, what's this one going to equal to? Lambda, right?
You just have to change the...
Yeah, it's got to be 3, no, well, 1, 2, and then 4. Dot, 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 all the way to n, right? You agree with that? So they're all equal. So let's look at the first two. If you take these two and set them equal to each other, what do you end up with? A whole lot of stuff cancels, and what are you left with? You end up with x1 is equal to x2. And then x2, what does that tell you? x2 is equal to x3, right? Do you agree with it? So that's when it's true. Okay, so when they're all equal, do you agree? So let's just choose, they're all equal to x1. Are we okay with that? They're all equal to x1. So let's look at our constraint here. We know that if you add them all up, what do they have to equal? You know that x1 plus, so you know that x of n minus 1 is equal to xn. Great. Don't move, don't move. Watch. x1 plus x2 plus all the way up to xn is going to be equal to n times x1. Do you agree with that? Correct. Okay. So let's look at this. So we're trying to maximize f of the original function, correct? F of, where is it? It's nth root of what?
x1 plus x. No, x1 times
It's the nth root of what? X times
x2.
all the way up to xn, right? These are all the same, right? So this is going to be nth root of,
n times x1.
not n times x1, it's going to be x1 to the what power?
Oh, to the n.
To the nth power, right? Correct? But we know that this is equal to c, right? So what does x1 equal? C over n. The nth root of c over n to the,
N.
so that's equal to
C over n.
c over n. Nasty, huh?